one and all. This is Shiv Chaitanya, currently pursuing computer science from VID Chennai. And today I am going to present my POC project on applications of context-free grammar in speech recognition. Today, in this presentation, I am going to explain what is theory of computation and context-free grammar and speech recognition, and I will explain you how the context-free grammar is useful in speech recognition. At last, in the conclusion, I will give you a complete idea about theory of computation and application of context-free grammar in speech recognition. Yes, Wendelberry said, we love beyond words, as also we love beyond competition and beyond theory. Words, computation, and theory are being used to make advancement in speech recognition technology. The theory of computation is a branch of computer science and mathematics combined that deals with how efficiently problems can be solved on a model of computation using an algorithm. It studies the general properties of computation, which in turn help us increasing the efficiency at which computers solve problems. This is done when we estimate the validity of the solutions given by the computer through the theory of computation and then alternate the algorithm so that we can come to a more reliable solution. This is a fast-growing branch that has helped solving problems in many fields besides computer science such as physics, economy, biology, and many others. Theory of computation is made up of three branches. One is automata theory, second is the compatibility theory, and the third is the complexity theory, where context-free grammar, our topic CFG, is a branch of automata theory. And going into the depth, automata theory is this is a branch was established in the 20th century by the mathematicians. The main aim in this branch is to analyze the behavior of machines and how they solve a problem. The most powerful model of the automata is the Turing machine. And the second one is compatibility theory. It is when we are able to formulate the problem using the Turing machine easily, but we can never solve it. In other words, it is when the computer is able to address the problem but unable to come up with the solution. And the third one is computational complexity theory. And this complexity theory discusses the efficiency at which a problem could be solved. This is done considering two major aspects. One is time complexity and space complexity, which are the measures of the number of steps needed to analyze and solve the problems and thus determining the memory space needed to solve the problem. In order to predetermine the space and time that will be needed, computer scientists linked these two factors to the amount of input that was received as the time and space needed increasingly nearly as the amount of input increases. Next, we are going to enter into our next topic, context-free grammar, and which is also shortly known CFG. A context-free grammar is a formal grammar which is used to generate all the possible partners of string in a given formal language. A context-free grammar is a way of describing a language drawn from a useful set of languages called the context-free languages. All regular languages are context-free languages, but not all context-free languages are regular. Context-free languages are shortly known as CFLs. CFLs are useful for describing nested structures, example expressions with properly balanced parentheses that occur commonly in programming languages but are known to be not regular. Let's go some more deep into context-free grammar. A context-free grammar consists of the following components: terminals, variables, substitution rules, start variables. terminals. It is a symbol of a alphabet. And variables. A second type of symbols that can be replaced usually represent the with capital letters generates a set of strings. Substitution rules are productions are simply rules. Rules that dictate how a variable gets replaced. The left hand side has the variable that is to be replaced and the right hand side has replacement is content. Start variable, a special variable from which the process starts. Context-free grammar provides no mechanism to restrict the usage of the product rule. Speech recognition. Speech recognition is already a part of our everyday lives, but for now still limited to relative simple commands. As the technology advances, researchers will be able to create more intelligent systems that can understand conversational speech. Given current trends, speech recognition technology will be fast growing and world changing subset of signal processing for years to come, where speech recognition used as a broad array of research in computer science, linguistics, and computer engineering. Speech recognition systems use computer algorithms to process and interpret spoken words and convert them into text. Speech recognition software must adapt to the highly variable and context-specific nature of human speech. The software algorithm that processes and organizes audio into text and trained on different speech patterns, speaking styles, languages, dialects, accents, and phrasings. The software also separates spoken audio from background noise that often accompanies the signal. Various algorithms and computational techniques are used to recognize speech into text and improve the accuracy of transcription. Below are the most commonly used methods. Natural language processing, and it is a very common thing in most of the speech recognitions, and it is shortly known to the NLP. And the second one is hidden Markov models, engrams and neural networks. Here, let's go with a flowchart or an image for a most understanding of the voice recognition. When we give a voice, there will be a three more steps to convert it into a speaker's ID. When a voice converts into speech enhancement, and afterwards the feature extraction will divide into two. One is for the trainee and the other is for the test. Where for the trainee is going to speaker modeling and the other test is go for the feature matching. And at last it gives a decision and which the decision is like a speaker ID where the speaker's database will store the complete data as a recognition, voice recognition. The present invention deals with speech recognition systems. In particular, the present invention relates to a context-free grammar engine for use in speech recognition systems. In such speech recognition systems, a computer system attempts to identify a sequence of words from a speech signal. One way to improve the accuracy of the recognition is to limit to a set of selected phrases. This context is based on the bakery restaurant project. With medium vocabulary of 1300 words, speaker independent, spontaneous continuous speech understanding system, and a Whiteberry recorder use the Whiteberry algorithm for decoding a bit stream that has been encoded using a conventional code or tailless code. A number of researchers have proposed ways to use natural language backend information in the speech recognition process. BARP consists of a RASTA PLP feature extractor, a multi-layer picryptron like it's shortly known for MLP, phonetic probability estimator, and a Viterbi decoder, an HMM lexicon, a natural language interpreter, which incorporates a stochastic context-free grammar and a database of restaurants. The SCFG used in BERP consists of 1389 handwritten context-free rules. The non-terminals in the rules are very specific to the corpus and hence encode semantic information particular to the restaurant domain. The rule probabilities are learned from the 4786 sentence BRP corpus with the EM algorithm. Figure 1 shows a sample of the grammar rules with the probabilities. With the above mentioned results, these experiments make it clear that the SCFG information can significantly improve recognition performance. It was interesting to note that compiling the SCFG into a bigram preserved most of the useful information. Adding the SCFG to the SCFG bigram only produced a non-significant 0.8% absolute reduction in word error. Many developments has been made on usage of context-free grammar in speech recognition for the past few years, and many experiments are being conducted to make significant improvements in the same. Advancement in the field allows speech recognition to be faster and more accurate. I sincerely appreciate and I cannot express enough gratitude to you, sir, for how much you have taught me this semester. Not only are you an amazing instructor that uses creative images and exuberantly positive personality and fun ideas like quizzes to encourage students to learn, but you are a truly an inspiration to me for my future goal of becoming a physician. Your dedication to helping other students trying to follow to in your own footsteps is exceptionally admirable, and I simply cannot overstate how humbled I am to have met and learned from you.